in the past, many times I still like to go out to primary schools, give talks and so on. And quite often I talk about Mars. So I take a lot of bag of Mars bars. And a question I ask them is, what have these two things got in common? I'm not going to ask you to answer it. The answer is actually on this Mars bar. It says a little bit of Mars. That's also a little bit of Mars. If anybody would like to have a little bit of Mars in their hand, I've got some. It's part of a Martian meteorite. It's a bit grubby because thousands and thousands of primary school kids have had it in their hand. Well, tell your mum and dad you've had a piece of planet Mars in your hand today, which they do, and hopefully they remember that and get keen on astronomy and so on, because it does make the day a bit more memorable than most school days. I went to see, I should say, I'm not one of those people who really looks through telescopes. I did run a program at Siding Spring Observatory from 1990 and 1996, searching for near-Earth asteroids. I'm going to hear, I'm glad to say, this afternoon from Alan Gilmore and Pat Gilmartin about their asteroid tracking program here at Mount John, which ran for decades, quite a few decades. Fantastic dedication to that type of work. But I'm not one of those people who actually really enjoys looking through telescopes, I'm afraid. Mostly I've done space research as such, which is what I do with Xerra Earth Observation Institute. I actually live in Nelson, but I travel around a lot. I left Nelson about 4 o'clock yesterday morning to drive back here, having got back from Auckland 12 hours before that. It was great to see the telescope last night, Bratier. It's what is called a great refractor. If you go to Wikipedia and look up great refractor, you'll find there's a page called just that. It's got a list of great refractors, great meaning big. If you go and see the Bratier telescope, and please do if you haven't. I love telescopes. I just got really interested in spending the whole of the night looking through them. I love old Victorian-style telescopes like that one. And the thing with that telescope is, because it's a refractor, a lens telescope, as you need to put it lower in the sky, the eyepiece goes up, which means the astronomer either needs to be on stilts or else needs a step ladder. And the first, on the Wikipedia page, the first listed great refractor is the Dorpat refractor. Dorpat was the German name for Tartu in Estonia. It was built by Joseph von Fraunhofer. Get the year, John probably knows, 1819?
1822.
1822. So, John and I have a similar interest in the history of astronomy. Anyway, the story was that particular telescope, 9.5 inch, I think, objective, was called Great Refractor mainly because so many astronomers have broken legs by falling off the step ladder. So, Joseph von Fraunhofer, the Fraunhofer lines in the solar spectrum are very famous, but a lot of people have never seen them. Yet if you've got one of these, they're very easy to see. And again, I urge people, come and ask me to look through this. This is called a direct vision spectroscope. I hope the optical company, in fact, they actually sell these. You can buy them online, or you can buy them at gemology exhibitions, where people who are interested in studying precious stones use these to look through and see what comes through. So you can see the Fraunhofer lines, the dicadron line, the solar spectrum, with a little thing like this, costs $70 or $80. They're also pointed at the screen or fluorescent lamps and actually see the emission spectrum, the emission lines. It's a really simple thing. Everybody should have one, really. Give them to people for Christmas. Okay, so I should get on with what I'm talking about. Earth's artificial rings. Here's an example. I was giving a talk last Monday in Auckland to the India-New Zealand Business Council Summit. And I was about 3 speakers after the leader of the opposition. I thought his talk was boring. I showed lots of nice pictures of satellites going in orbit around the Earth. Those are just Indian satellites. India has 59 satellites in low Earth orbit and has many other satellites higher up, including an astronomy research satellite. So, just a couple of things about me. It happens that I wrote, my first book was this one, Rogue Asteroids and Doomsday Comets. That was the book which spawned the terrible movies Armageddon and Deep Impact. I did a coffee table version for Reader's Digest in that year 2000. Also led to me making various TV documentaries in which I was described as being a doomsday astronomer, as you can see. We filmed that October of 1996, and that was shown on Discovery Channel every week for 4 years. We won an Emmy for it. It was seen by 400 million people, 6% of the human race. And they only stopped showing it because of this, that is the World Trade Center, of course, was taken down calamity in 2001. And so that's the first shot in the whole. It's a 2 one-hour documentaries together, and that's the opening scenes. Me in this helicopter. They also shot space shuttle disaster occurred, I was actually living back in the UK at the time in Knutsford, King and Ute, sorry, Ford in the river. And I was doing the washing up, and I got this phone call from the comments or opinion editor at The Guardian, said, "Have you heard of that space shuttle?" I said, "Yes, yeah." He said, 1,000 words, 2.5 hours, £500. That's all he said. I put the phone down. And I think it's probably the best thing I ever wrote. I had 2.5 hours to get out the thing. Anyway, I've written various other books, Clips books, that's the US edition. This one was published here in New Zealand by Able Press out of Wellington. We also did some radio things. What else have I got here? Oh yeah, I've worked on space debris for many years. You can tell this is an old business card in Adelaide, in Australia, but it's got a fax number, no internet, no email. This is from 30 years ago. I write a blog called Outer Space. This is on the Sidelog's website, which is run from the Royal Society of New Zealand in Wellington, and this was one I did about this specific conference. Although it says Night Lights of New Zealand from orbit, because that's what I'm talking about on that poster. With the back there, that actually is Portugal in Spain. That's what it looks like from the space station. I've also got a Wikipedia page, which is all out of date. It says I'm still living in Wellington, which I wasn't until about 6 years ago. Just wanted to say it's really embarrassing, but it's got your date of birth on there, so not only does it tell you how old you are, but when the bank calls you or somebody and they say, "Oh, what's your date of birth?" It's a useless security question, you know. It also tells you where I was born, and further on down it actually says my mother's maiden name. It's all standard questions. On the Wikipedia page, I haven't, anybody been invaded by bank accounts? Anyway, satellites are a major source of light pollution, and going to get much worse. Here's an IAU, International Astronautical Union statement from the 3rd of June. About light pollution and how it needs to be kept under check, please, from reflection of sunlight by satellites. All these lines are the so-called Starlink satellites, which I think SpaceX are launching. I saw just last week there was approval in the US for a constellation of 32,000 satellites in order to give 5G internet to the whole globe, which is a good thing in itself, but it's going to cause us problems in other ways. Another thing in the media I've seen just recently is there should we and can we advertise in space? I think I know what everybody here would think about that. And it says, this provokes dismay from anyone who might prefer an unadulterated view of the night sky, astronomers very much included. Again, I think you'll agree with that. Did I mention June 11th? That's my birthday. Everybody knows that. Here's another thing which I'm sure people will be aggrieved about, but actually I wrote a letter of support for this because I think we've got to be reasonable in various ways. This is a company called ALE, it's called, nothing to do with beer, Astro Live Experiences, based in Japan. They are putting up these cubes like this, and in there is a set of ball bearings in essence. And the idea is they release the ball bearings on trajectories which will lead to them entering the atmosphere and forming a artificial meteor shower. They've already got one satellite up. They're planning to do one. That shower is, I think, going to be in January over Hiroshima. So the satellite's in position, as it were, and will release at the right time. It's a test for a second launch in which they want to actually have something like this occurring over the Tokyo Olympics next year. And I've just heard last week that they have got approval for the launch of that satellite from the New Zealand Space Agency. It will be launched from the Neil Peninsula. Again, some people will get very upset about that, but actually when you look at it in detail, it is in a very low Earth orbit, and even if something goes wrong, okay, the particles it releases and the satellite itself will re-enter in quite a short time frame. There are other things we need to worry about. Okay, here's a picture from the space station, and a lot of people think, oh, this is just like long time-lapse photos we see of the stars going around the south or the north celestial pole. But actually, it isn't. The curves of the stars are due to the motion of the space station over 11 minutes. In fact, this point here is the northern pole of the space station orbit. And what you're seeing down here is these are actually fires in Africa. These are cities being stretched out over a series of frames. And all these white things are flashes of thunder and lightning. And you can also see a few satellite trails. Here's on your rotating satellite. Here's one following up. What appears to be a curved orbit, but of course that's due to the space station moving. When you want to take a look and see, well, when can you see satellites? Most people go to this site, run by Chris Peet out of Germany. Heavens Above, I very much recommend it. It is wonderful. In putting together this talk, which I'll move along with rapidly, I thought that, especially after yesterday, I actually put this talk together about midnight last night because I wanted to see what was happening at the conference and what people were talking about. My view of these sorts of talks is it's only an advert. It's like when you see an advert for a movie on TV. They show you the best bits and so on, but the whole movie you still need to see. And I don't try and give the whole story in a 15-minute talk. I just want to give you some idea. So let me give you some ideas of what sort of orbit satellites are in. We saw just now in the previous talk from Mike about Landsat 8. Here's a particular pass by Landsat 8 coming over to New Zealand. The purple, the violet I've shown there is actually the coverage of its sensor. Yeah. Okay, moving along, here's an actual image which I put into a 3D environment in order to show how it's grabbed an image for that particular pass. Here is how it builds up the image, and here is it building up the image as such. So we can do that sort of thing. That's the top of the South Island in New Zealand. I've got plenty of movies like this. If anybody really wants them for like the tourist things here, so I'm happy to talk to you and see what I can get ready for you. Chasing rainbows. This is actually the taken Sentinel-2 data, which is 10 meters resolution pixels. This is Otago Airport. There's the airstrip. This is something I did with Andrew Taylor, who was the PhD student after me at the University of Canterbury back in the 80s, beginning of the 90s. This is all his students from Christ College, and there's me at the end. What they were doing was they were going out when they knew there was a Sentinel-2 satellite pass and watching what traffic was coming by. So what rainbows are they chasing? Monitoring road traffic using multispectral satellite imagery. See here you've got two things which go from red through green through blue. The resolution isn't real good, but what they're actually seeing there is white top camera bands which are moving along. And there's a very, very short time delay between the collection of the imagery and the different spectral bands. And so the band has moved along by about 10 meters, the resolution of the pixels here. So you actually see a red image of it, then a green image of it, and then a blue image of it. Everything else which is held still is showing in real colour, as it were. But something which is white top, you'll actually be splitting up. Of course, they actually take a look, knowing how long the time is between the different colour imagery grabs to see whether it correlates with the actual speed they measure the guys going at. Pretty nice project for students. It's been very easy. Okay, satellites. There's lots of satellites up in geostationary orbit, which is at 35,800 kilometres above the equator. Here I'm just showing a few of them. This is how we watch the Rugby World Cup back from Tokyo and that sort of thing. Okay, GPS satellites. Everybody seems to use GPS in their phone or in their car, but don't really know what sort of satellites are delivering the data. Here is the GPS constellation, which is run by the US Air Force. I've actually been in the control room at Schreiber Air Force Base here in Colorado Springs. The first time I ever had to do an iris scan, going through security. And you need at least 4 satellites. So that's that constellation. Another movie, there are others. Here's the European Union one, and it is the European Union, not the European Space Agency. It's called Galileo. It's being completed now, will soon be coming fully online. It should be 3 orbital planes. You'll see there's actually one of the orbital planes there, one of those ellipses, actually has only 2 satellites in them, and they don't talk about those too much because they got put in the wrong place. About $500 million each. The Chinese have got their own constellation called Baidu, and that actually is currently 53 satellites, and you can, like I said, for GPS you need at least 3. We'll take a look and see how many you're getting here at Hong Kong and Beijing. That actually is a very high precision system, as you can imagine. The Russians are also finishing their system, which is called GLONASS. Here's various satellites in low Earth orbit. There are lots of them, as I say. Earth's artificial rings. Isn't that exactly what we're seeing there? Here's some of the orbits of them going around. The white line, I should point out, the International Space Station.